Great. Well, thank you everyone for joining my talk, and thank you React Advanced for having me here today. We're gonna run a little experiment. My laptop was not working, so I have I'm gonna be I feel like a DJ with two laptops at the same time, and I have one connected to the other one. Let's see how it goes. So today we are gonna be talking about how Hopin is moving 10 times faster with microfrontends at scale. First, let me introduce myself. My name is Alex Lobera, and I love React, TypeScript, of course, microfrontends, salsa, bachata, and my partner. And not in that particular order, of course. I work for Hopin and as a senior staff engineer, and you can find me on Twitter in Alex Lobera. This talk is about microfrontends architecture, and in any architecture, everything is a trade-off, right? We are constantly making decisions about what's best for the job. We are weighing different options. Oops, sorry. Let me fix this. Yeah, we're in a React conference, so I guess React weighs more. So we're always weighing what is the best option. And in order to understand the architecture, you need to understand the context. So let me share with you the context in our application or in our organization. So Hopin has acquired different companies. We have here an example. And the way we organize is by product areas. Then we have teams that work on those products. Companies have technology stack. In the case of Hopin, we use React. Jam uses Vue. We might want to mix and match technologies across different products. And very important, teams work in the same UI. We have small teams, and you can have a single page that has different features, and every feature is owned by different teams, all together in the same page. And we want those teams to be able to work very quickly without stepping each other's toes. So now, what's our definition of microfrontends? So for us, microfrontends is an architecture, and we think of it as a software applications where we break up apps into a collection of smaller apps, and they have a series of characteristics. First, they are organized around business capabilities. They are owned by a small team. They are independently deployable, and very important, they are loosely coupled. Here, for instance, we have a UI, and there is two features. I'm going to call them apps, because for us, features should be able to work independently without the context of the larger app. So here we have a chat and a user profile. Then every team is going to be able to deploy them independently. They will build them and deploy to a CDN. Then we use Webpack to pull those dependencies using module federation, and we integrate them at runtime. Once we have those scripts, what we do is we mount them on independent component trees. So here we have two features, two applications, and so we'll have two independent component trees with two roots. We might want to share some state between them. We don't encourage engineers to share state between the microfrontends, but there are some cases where we might want to do that. And to do this, we have a very lightweight store that is going to enable teams to share some state. And it's a very simple store. It cannot derive state, for instance, unlike Redux or Recoil. Those, we believe they are too powerful for this paradigm. And so we have a more simpler implementation that will push all the state logic inside the boundaries of each application. Again, our goal is to have a very decoupled system. So let me show you a demo. Now is when things get funny. First of all, I'm not using my laptop. And oops. So here's the first experiment. So I'm going to be switching to the other laptop. So here what we have is some React app. And we are rendering it here. You can see the component tree. I can move over the tree and see that if I am over the input, you see also the input highlighted on the UI. Same for the button. And I can also look at the network tab, and I'm pulling some dependencies. I can filter by React here. And you can see I download React and React DOM, because we need those to mount this application. But I can also look at this in the context of a Next.js application. And here, if I look at the component tree, I can see this component. This is the Next.js app. I can scroll down. And when I get to this point in the tree, I see that I'm highlighting the user profile, but I don't see the input and the button that I saw before. So we have this mount Microfrontend. I can scroll down, and I can see another tree. I can see my input and my button here. So there are two distinct trees. I can also look at the network tab. And if I filter React, I see that here I'm not downloading React or React DOM, because in the context of the Next.js application, Webpack Module Federation is sharing those libraries with the React app. Let's have a look at this mount Microfrontend that is receiving some URL and some name. So I'm going to switch to the other laptop. OK, WebStorm. How do I make things larger in WebStorm? I don't use WebStorm. Does anyone know, like, if I do command plus?
Pinch the zoom on the...
Say again?
On the touchpad, zoom. Pinch the zoom. I just...
Oh, that was too easy. Just React Advanced, thank you. You learned something. I did. So let's go back. I'm going to look at this mount here. And I want to look at the mount function. So what I do is I receive a URL, and that URL, I will load some scripts. When this is ready, it means Module Federation is ready to load some script, some module in this case. What I'm going to load is the profile. And I have it in here. This is the entry point. This is the entry point of that application. Notice that I'm not exporting components. I'm exporting a function that has an argument, which is an HTML element. And what I'm going to do is I'm going to mount my app on that element. And I'm also going to return an unmount function to clean up this. So I can go back to the other laptop. And I'm going to collapse this. And I can go to the chat. Then I'm mounting this other application, this React app. I can go back to the home page and mounting and unmounting. Why do we do all this, right? The reason we are doing this is because we want to decouple our applications. And if we render everything in the same component tree, then we could potentially add some Redux or whatever on the context, and then all my small applications would use that implicit context, right? And so that's bad, right? Because if tomorrow I change the Next.js level application Redux for something else, then I also need to change my other applications. So here, for instance, we have a provider. And if I want to use this provider on the other side, I will need to also add the provider in the context of the other application. And then what I will need to do is I will need to explicitly wrap it from one side and pass it to the other one. right? When I mount in this create root, I get the context from one side and pass it to the other one. So the reason we are doing this is because we want to create boundaries. And that's very helpful. That's very helpful because, well, before. So one thing we can do is, speaking about the context, I want to show you this provider that we were looking at, this reactive map provider. So this is the lightweight store that I mentioned before that we use. And so I can use it, for instance, to add some name. Right? I want to change the name on one side of the application, but I also want other places in my app to react to it. So if I change the name to Alex, then this reacts, which is a different application. I can look at the profiler, and I can maybe add something here, record, save, see what happened, and only my chat was the application that reacted to it and was rendered. So this is really nice. Now we have boundaries, and then we can mix and match, as I was saying before. Let's say we have a Vue.js chat that, it's just a chat. And just for the purpose of the demo, I'm not saying that we should do this, but let's say we want to replace React with Vue. And so I could go to this other laptop, and in the page where I'm rendering, when I'm rendering this, I'm going to change for 87, right? I have on this port, I'm running the Vue.js application. So what I'm going to do is I'm going to change this. And now if I go to the other app and I reload the page, I don't have the Vue.js application, which is very interesting. Sorry, I got it. I'm getting confused with this laptop. So if I change it in the right place, and now I go to the other laptop, and I reload this page, I have the Vue.js application. Woo! I never thought I was going to be get this round of applause for showing Vue.js in a React conference, but you never know. I can look at the elements and select this div here, where I have this Next.js application. Notice that it's highlighting the entire app on the browser, and I can select this. I have this Vue.js inside a Next.js application, and it actually works. And I can also change my name, and it also reacts to it. Similar, it's the same experience, the same as I did before. Why is all this happening? Because we are creating boundaries between our applications, and because we have explicit contracts. As long as we comply with those contracts, everything should work. OK, so I go back here. So that's cool. That kind of works. But what if I go that path and then I have 100 application, maybe I don't know, many applications, maybe React component trees in my app? What's going to happen? Is this going to be performant? I don't know. Maybe some of you are wondering that. So I thought of preparing a demo for this. And I have this benchmark, which I'm going to. So here what I have is one React app that can't mount many apps. If I look at the component tree, I have one app that can mount many other apps. You see the create root here, as we have on the other side. I can render, let's say, 10 apps. So I'm mounting 10 applications here. I can also say, OK, I'm going to render 10 components each. Now I have 10 apps with 10 components. We can see the memory on the left. And on the right, we have a clock. I'm changing that using JavaScript. So if the thread gets really busy because we are mounting and calculating trees, then it will freeze. So let's do an experiment. If we run maybe, we don't have a lot of time, so let's go straight to 30,000 components. Let's see how long it takes to render on my laptop 30,000 components. So that's going to be around 6 seconds. Let's do it again just for fun, so I can waste a bit more time on this. 43, it's going to be around 49, 6 seconds. OK, nice, it's consistent. So what if I render 3,000 apps? How long is it going to take? Oh, it was 2, 3 seconds. Let's do it again. Same, 2, 3 seconds. OK, let's do the final test then. Before we rendered, we mounted 30,000 components. So now let's mount 3,000 apps with 10 components. That's going to be the same, right? Let's be fair. So what do you think is going to happen? I have 3 minutes left, so let's go to it. 10. And, oh, that was interesting. Wait. Four, 5. So what do we learn here? Well, it was faster, and I have some benchmarks I want to share with you here. I did it with 100,000 components and a few combinations of those. As you can see, memory-wise, didn't change much. The time to display those changes was different. React will take more time to render many component trees. However, there is not only React. You also need to paint those changes, and the sooner you start painting, the faster it is. So as you can see, if the more you increase the numbers, there is a significant difference here. So all in all, it won't make your app slower to do this. I'm using React 17. I expect this to be probably insignificant, maybe, with React 18. But the point here is, you don't do this, you don't break your app into many apps because it's smart, it's faster. You do it because you want to create boundaries, because you want to decouple your code and your applications. So some principles: create boundaries. You can create multiple component trees. It's safe. Use explicit contracts. Use explicit contracts. If you want to share some state or context from one place to another, make it explicit, get it from one place and pass it to the other one. And if you decide to share some state, I recommend you to keep the state logic inside the boundaries of your app. And for us, we use very simple store that cannot derive the state. It only communicates stage changes. And we believe that Redux and Recoil, for instance, those sort of tools are too powerful for a paradigm like this. You can still use Redux, but you use it inside your app, not to communicate between your apps. Thank you very much.